Next up, we have Huamin Chen. Huamin is a passionate developer whose recent contributions to the CNCF ecosystem include Project Kepler, Tag Environmental Sustainability, and Cloud Native AIWG. He is also one of the founding members of Kubernetes SIG Storage, member of Ceph, Knative, and Rook. He previously spoke at KubeCon, OpenStack Summits, and other technical conferences. We're looking forward to his talk on vLLM Semantic Router. Please welcome Huamin.
Thanks, Jason, for the introduction, and great to see you all. And hopefully you have a good time tonight. So this is a very nice segue from Steve's DIY kind of style, do your own inferencing, and then we are going to production. When it scales up, you find out things comes to break. That's where the innovation comes from, the golden rules of computer science. And then when you scale up from one single VLM with the 4 NEs, as Luke just mentioned, you can scale up any type of models, any kinds of software, any kind of instances in all kinds of clouds. Things starts to go messy. Now you have thousands of potential LoRa plus base models combinations. You have different workloads you want to serve. How to orchestrate these deployments with the user workloads in mind to make it the best cost-effective solutions for the enterprise users. So what this vLLM Semantic Router is about is to manage that situation for the developer, for the data center admins, and also for the model service providers. So let me just start from the problem statement. So each of you already have used vLLM for inferencing. One of the easiest ways to use the API, the OpenAI compatible formats. You just do a quick curl, and then you can get your inference result come back from your command. So in a single curl commands, there are quite a few informations you have to figure out by yourself. Which model you want to use. There's so many models around, and with so many specializations, people are talking about LoRa's, and what's the the expectations of the results, whether that is a casual, just like Steve doing a quick test, or for production, you want to run a real systematic evaluation of your models. And with that in mind, what's your expectations on that? So with that information in mind, it comes to the application developers to pick up the models, pick up the deployment scenarios, and what's the expected results come from the models. All these 3 things will make the developers' job really hard. How to make that happen. I give a very simple curl command here. Within this, there's 2 issues you can identify quickly. One is the model. Why do you pick up the specific models over the other? What's the science behind picking up the models? And what's the accuracy criteria that you are looking for once you put this piece of code into production? So that's at least 2 issues you have to consider. For small models, we are using the Llama 3 for convenience. But if you are looking at the model metric itself, you will find out for the specific questions that you are asking, what's the derivative of x squared? That's a specific math question. Llama 3 is not your best choice. If you're looking at the different benchmarks, you are going to find out for the same site, you can pick up with the Qwen 2. On the other side, if you are running some of the commands for creative writing, or some STEM categories like chemistry, you are going to find out Llama 3 is actually the best choice. So finding out the best models for your workloads is one of the highest criteria for the best conforming applications in production. So that is one of the specific questions we are identifying from a lot of application developers. The second question is, as more and more people are using the reasoning model, so if you are using one of the latest reasoning models like GPT-5, you are going to find out each time you go to ChatGPT, you get a prompt, whether the model is thinking harder or just briefly thinking. The so-called thinking model is to generate a series of contents, using that contents to start off the process called chain of thoughts. From that process is coming up with the actual results that the model thinks will give to that result. Chances are you're going to be battling once you go into production. Once you're going to that environment, you are going to be battling with at least 2 scenarios. One is that are you using the reasoning in the right way, meaning that you want to reason hard or reason lightly, or Are you using the right amount of tokens allocated for the reasoning content? These two questions are kind of related, but not always the case. For example, one of the open source models from OpenAI is GPT open source OSS 120B. This is the bigger model. The smaller model is 20B. If you are thinking that the bigger models always deal with the complicated questions, you are on the right path. But how do you define hard and easy questions? That is opaque to you. For questions I'm using here, what's the 100th Fibonacci number? It looks on surface a hard question, but it's actually not. So if you are using the 120B model, you are using the wrong models for that purpose. The 20B will just do the job right. The second thing is that you are allocating the max tokens. The max token is the parameter you tell the vLLM to generate how much content for the reasoning and eventually for the chat completion. 100 tokens to generate a reasoning model is not sufficient. What the amount of tokens you want to use is actually a kind of alchemy, so to speak. It's not something that you can straightly forward infer from the models or from the questions. It's actually there are certain benchmarks you have to run in the background to make it happen. So with that three scenarios we have in mind, choosing the right model, choose the right, the reasoning efforts, and choose the best max tokens, which is the cost performance benchmark. Then you come up to the question: are we dealing with the programming, Gen AI programming in the best way? So if you are looking at all these scenarios, it reminds us in the early days of computer science, you are writing programs like in assembly language. You have to know very well with the details of everything. You have to know the model very well. You have to know the capacity of the GPUs and the backend very well. And you have to know the exact cost of tokens, latencies, things like that. So you are dealing with the very primitives of models. So this is not the way that the computer science growing up with. So we are used to high-level languages like Python and Golang in certain spaces. So you get so used to it. We are no longer get used to the low-level stuff. So to make the adoption of Gen AI applications to the extent that can be easily adopted, we have to be more creative to expose the details of models to the end users. So that's why one of the motivations we are coming up with the high-level abstractions of getting all these details away in the routing layer. So when you are dealing with the models, you only need to specify as little as we desire, and then we expose as much as we can to the accuracy, to the cost, to the latency, to make your Gen AI app happy. So in a very nutshell, actually this is good. In a very nutshell, what we want to, the end goal that we want to achieve is that you specify just single parameter. It's called an auto. You specify an auto model, and everything else will be left to us to handle. Now we pick up the best models based on the workload, the intent of what you really want to do. And we figure out whether that is a trivial question, it's a hard question, that this requires reasoning, that this requires more tokens based on the cost and performance issues. And then we get the best models for you, give the best configuration of your prompts, and then we let your prompts go to the right models right away, without a lot of latencies in between. So this goes to another level of scalability. If you have a lot of concurrent queries, how are you going to scale this up? You can definitely do it on a DIY manner. You can write a very wonderful program to do everything, but that won't scale. Right, so the vLLM Semantic Router, which is a project getting into the vLLM community just 2 weeks ago, gets a lot of attention. We get now 1,200 GitHub stars. We get almost 20 committers in a 2 weeks time window. And we are really getting a lot of attention in the community. So what we are using is based on a lot of frameworks that has been created by the community, one of which is called Candle. So if you are familiar with the Gen AI ecosystem, the Hugging Face is really a big community behind a lot of libraries, data sets, and models. One of the framework from Hugging Face called Candle is developed for the purpose of high-performance computing with Gen AI, with transformer libraries. That is written in Rust, is really designed for scalability and efficiency. And we build the kind of libraries for the purposes that we are going to use, and create GoLang libraries around it. This is for the purpose of people using the GoLang for cloud native development. And then from that point on, we integrate with the Envoy AI gateway. So if you are familiar with how HTTP service or kind of web app is being served in the cloud native or CNCF or Kubernetes environments, then most of them are based on Envoy. We create that framework to hook up the Envoy, and then we make the magic happening in the background. We use the burst classification, one which is being a topic in the PyTorch. I just saw the burst classification talk went through in the slide just by Jason. I think this is one of the wonderful technologies used by community. So what we do is that once we get the prompts, we figure out by burst classification, figure out what the prompt is about, and then we pick up the best configurations based on those configurations. So we build up we fine-tune multiple modern birds-based models to classify different scenarios. So we classified the intent of the workload, whether that's the math, physics, creative writing, things like that. And we also classify if this prompt safe to use or not. Does it contain sensitive information? One of which is like a PII, personal identification information. So that is something if you are enterprise care a lot. Once everything is cleared up, we just let the request go into the original format. Pick up the best models, pick up the best configuration of using the models, and send to the vLLM backend. So if you are just putting everything in yes or another writing, the goal of this vLLM Semantic Router is really to abstract the details of how you are dealing with models to scale up your production, scale up your application development. We want to provide an open source way to democratize the secret ingredients used by many of the powerful frontier model providers like OpenAI. The latest OpenAI GPT-5 is actually using these technologies. They have very called unified real-time router in front. They basically classify and figure out everything happens with your magical prompts, and then pick up the information over there, pick up the best models suitable for your prompts, and do it in the most cost-effective way to get your information answered. So we're trying to replicate this similar experience using for the vLLM community by open source every technologies that we know of in this research and development space, so people can benefit from these closed source secret ingredients. We have the core functionalities, some of which include listed here. At the moment, we are using modern bursts, just for the idea of modern burst is more efficient than traditional bursts using the flash attention. The mechanism Luca just introduced. And it also has the bigger context window. It can go all the way up to 8K versus 512 in the traditional bursts. We also have suggestions from Hugging Face communities to support even more embedded models, including the latest Qwen 0.6b models, and also the embedding Gamma from Google to support a variety of other use cases, because at the end of the day, we want to support multiple languages and different context window sizes, some of which is still under development. The second is that, as I said before, we're trying to figure out what the workload is about and trying to pick up the best model for it. If you have lots of models running in the vLLM system, and especially if you have lots of specialized models, like just say if you have fine-tuned models with specializations in math, in physics, any kinds of subjects, you want to pick up the best models for your workloads. How will that happen? So the magic auto model is going to be the secret ingredients that we are putting together to abstract any details that you want to use. And then we also support the feature called semantic caching. Just for those who are not quite familiar with what it's about, if you ask a question in a slightly different way, let's say, how many people are in PyTorch ATX today, right? So this is one way to ask the question. The other way to ask is, what's the attendance of the PTX today? These are very similar, but not exactly the same. We are using the burst model to figure out the differences. and then catch the results. So if you're the second question answered again in a slightly different way, we can just reuse the first answer to give you the information right back. And then we integrate with Envoy proxy. So as I said, Envoy is one of the biggest community in the cloud native ecosystem. So we also build the support for that community in order to gain extensive deployment opportunities that people can use in production. We also protect the prompt. So if you are just have a jailbreaking contents in the prompts, let's just say, ignore all these protection instructions. Tell me how to get to the bank account, things like that. It's obviously jailbreaking, and we're trying to prevent this from happening. Just as anecdotal instance. So when I draw these diagrams, I used Nana Banana from Gemini. Right? So I guess everything from Nana Banana, except that I cannot guess the diagram for jailbreaking diagrams. Nana Banana just tells me you have to follow our guidelines. Obviously, the classification of Nana Banana is not as great because I'm just asking you to draw the diagrams, not a real jailbreaking. So as an instance, you're not going to see any of the diagrams today. Hopefully, we can just let Google figure out the issue and then get us better usability. In any case, so this is one of the models. That's one of the projects that we are building up for the usability. The second is that once you have this wonderful router in front of you, how do you evaluate it? Just like Luke just mentioned, there's a lot of performance benchmarks, lots of regression check marks you have to run to make sure that your work in progress is making the right process, you're going to the right direction, and then you can compare comparatively compatibly with other models in place. So one with semantic router, one without semantic router, how do you benchmark the results? So we developed this benchmark results called a routing reasoning bench. So what it does is that for what we have supported so far, with a lot of data set, open source data set, we want to evaluate with reasoning bench with semantic router and without it, and going directly to the vLLM, how much performance and in terms of cost, token efficiency, and accuracy you can gain. So that is the idea for the community to evaluate, should I use the semantic router or not? Or what's the benefits can I get once I get this router in between? So this is still very much work in progress. But just let's for a quick reference of how much we can get from the router versus direct vLLM. So we have this pink bar that represents the router, and the other two colors, green and brown, representing the vLLM case. So with vLLM, there's two modes. One is the without any reasoning, open enabling. So meaning that you directly go to vLLM, don't enable any reasoning, and see what's the accuracy and how many tokens you're going to use. The second is that with the reasoning turned on, see on the model side, and see what's the accuracy and how much tokens you're going to use. Remember that as a rule of thumb, whenever you enable reasoning, you potentially will see higher accuracy at the expense of more tokens. So this is a trade-off you have to balance. So what we see in multiple benchmarks, in all these benchmarks, we see that with the intelligence router sitting between, that's dynamically turns on and off reasoning, we see that the accuracy is usually one of the highest, with the exception of this green one. The green one is one of the data sets that has the human annotated chain of thoughts. It's not based on the reasoning modes by the model. It's actually human annotated. So that's one gets higher accuracy. So we still run this. This is still pretty much work in progress. Maybe when we get more information, and then we can get some more conclusive ideas what is actually explaining this difference. But in general, we can see across the board, mostly across the board, we can see higher model accuracies using the router, or higher or equivalent in that sense. And if you look at the other metrics of how many tokens being consumed in order to reach that accuracy, and you can see usually the semantic router, which is in blue, using a fewer tokens than the other unoptimized direct vLLM access. So this also happens across the board. Now let's just see what the demo environments look like. So we have a front-end chat UI. So this is our UI that is written in Streamlit. And we also have Envoy proxy to connect with the UI. So whenever you send a request, the request will be sent into the Envoy proxy. Behind Envoy proxy, there's Envoy xproc, which is basically our semantic router. Within this semantic router, we have this fine-tuned burst model. That's where just classify what's the prompts category, and then using that selection to pick up the best models for the rest inference. We also have a semantic cache, which is basically just a cache similar request responses. So the next time, if you have something similar to ask for, that if that similarity above certain thresholds, the previously cached response will be returned instead of getting from the models again. Within this setup, we have three models that are in our inference engine. The first one is a Llama 3 27B model, and then there's a Mistral small model, and also we have a 5.4 model. We have previously benchmarked each of the models in a very small data set based on MLU Pro. So the overall idea is that we want to get some information about the model's accuracy in different categories. So this is what we see in the overall benchmark results. We also benchmarked our own model selection, which you see here in the auto category. So if you are looking at the overall accuracy, I'm just highlighting it here. So if you look at the overall accuracy, the auto model selection is outperforming both all these three underlying models. Right. So the benchmark result is used in our configuration. We basically have leaderboard information in our configuration. So whenever we classify a prompt, we just pick the models based on their rankings from this leaderboard information. All right, without further ado, let's just starting with the demo. So the first demo of prompts come from the MLU Pro in the category of economics. You can find this question in the MLU benchmark results. Let's just see if that is something we can find out. And you can also find the results in this benchmark from there. All right. Okay. So as we are looking at a question, so you basically can guess what you need from the testing rows in the MLU Pro dataset, and then we're using that in our testing. So remember, the correct answer is E. So whenever we see models doing the right thing, it will just produce answer E. So first of all, we are just using the semantic router, which we are just using the model auto. Auto means that we pick up the best models that is excelling in that category. Let's push the models to work. So the first time the prompt is being processed, it's going to the backend model, and it take a while for the results to come back. And we will see, once we have a semantic cache, the second round of the same query or similar queries will be much faster. Okay, so we get the answer back in 24 seconds. So the answer is E. It's matched with what we get from the benchmark results. Oops. Right. Let's just run these queries again. So it's in the second time, so it takes 0.18 seconds. So because that's come from the cache, even though this is the exact match, we can also see if you are running similar tests, if the prompts does not have to be identical, they just need to be close to each other semantically and to match with the results. Okay, let's just run the queries using a different model, underlying model explicitly. So we see here in economics, some models are doing better than the other one. So the chances are we got results from a JAMA S3. Let's see if that's the case. So we have a dashboard here, which basically just tells you what is going on in the backend. So we see we have a one conversion from auto model to the JAMA 3 model, which means that the router actually pick up the right models based on the readable results and the classification, obviously. If we are running the results on a different model, so let's just say we are using the Mistral small model. Let's see what could be the results. And let's just copy the question again. So remember the correct answer is E. Again, this will take a while because the actual processing on the models will take a few seconds. Okay, so Mistral actually gets a different answer. It's a none of the above, which is not correct based on the MLU datasets. So this just gives you some overview. That's why picking up the right model for the expected domains makes a lot of sense to improve the model accuracy. All right, that's it's the end for the demo. So very lastly, so this is the documentation page, aka our website on the left, and then our projects on the right side. We hopefully, share what you think is the best way to give the, abstractions to deal with models. And then if you are able to participate during the discussions, that's highly appreciated. All right, with that, I will just hand over to Greg. Oh, questions, obviously. Go ahead.
So the semantic router pretty much does the intent classification, and
Uh-huh.
based on the selected intent, it routes the request to a destined model server.
That's right.
Within the same session, if there are multiple requests, does all requests goes through semantic router every time for intent classification?
Yeah. So that's why we have to pick up the most scalable solution written in Rust, not the Python way. We also have to pick up the best models, classification models. We are using modern BERTs versus traditional BERTs. So all this for the concurrency. If you have high concurrency request, how fast we can serve.
So back to your example, there's a math question, there's a healthcare question. If within the same session, because this is a conversation, there could be more subsequent requests coming.
Okay.
Every time I'm asking a math question, I'm still going to go again and again intent classification.
Yeah, that's right. Because as you are asking the math question, potentially we also ask a similar questions in physics. So in that way, there's no, it's not a pure math. It could be physics in the subsequent, conversations. So that's going to be a tricky part. If you are just say, this is a very simple question of what's the derivative of x squared. That is a very straightforward math question. But if you are asking, once you apply that math question in physics, how are you going to solve it?
There's a danger because when you have multiple models, each of them responding in one request within the same session, you're poisoning the context.
That is the price we're going to pay. As we just said, you pay for the accuracy expense. But at the end of the day, I think the models are getting, the token expense gets lower and lower. I would expect people are more care for the quality, not the expense. So that's the trajectory we are aiming at right now. Yeah.
So, as I understand it, you first are going to select the model, and kind of working on a project that would actually let you switch models mid-answer. So like you're generating tokens, then you configure that. Maybe after the first 100 tokens, you want to change to a different model.
So we can do it in a similar way. So if you already have the partial, if you have response from one model, you can actually check the confidence of this request by calculating the log probability. And then that will give you some ideas whether this model is confident on this answer or not. If the model is not confident, then you switch over. But we're trying to do it in the first pass. We're trying to pick up the right model, not just get the response and trying to figure out if they're confident or not. So.
One where I see this working really well is essentially in systems with multiple agents, where you just take like a sub-agent prompt, call the router, get the right model for it.
Yeah.
With a supervisor agent.
Yeah. So if you just have a wonderful app to do everything, that's great. But we are addressing the problem of scalability. If you replicate your projects from projects, do you still have to rewrite your framework, rewrite your app in the same way? Or versus you do everything through the router level that's automatically give you everything. So that's we are balancing the usability of the applications as well as the people here sitting that's for the management. Yes.
Okay, so you have a model automatically selection of the model.
Mm-hmm.
For existing models and existing topics, you make a configure that.
Right.
Let's say in our business we have some topic, magical topic, and we have a magical model specifically for that. And we influence that into semantic router.
That's right. So we are basically just using the burst classification. So if your business have your own preferences for classification, you just train its model. So that everything we are doing just allow you to make everything happen in the background. So we do not dictate which category you are going to use. We are just using that as an example to prove that once you have your category classification model in place, we can route your request to the models that you want to have.
Show how to create the classification model?
No, we do not show the training processes, but if you are looking at, this probably has some flavors. So we basically, if you look at the modern birds rectangle, so we use the intense classification through modern birds, and then using that to pick up the models from there. So if you have your wonderful workloads specifically designed for certain models, and you want to use that, for example, legal. That's probably one of the best. Yeah. So if you have a customer service chatbot, have some legal questions, you definitely want the question to be processed by the strongest model that's specialized in legal. But if you're just for pricing, you can go into some other models. But for legal, you probably want to have some strong models to process that chat. So that's why we are trying to figure out, give you the process how to make that happen. It's all customizable. So we open source not just the framework, we also open source the fine-tuning process and how to create the best model for you.
All right, everyone.